Greetings guys. So here are some questions that are based on differential equations. So the first question says, now A, we are having y prime minus y, which is equal to 5.2. So we can put that as dy over dx minus y, which is equal to 5.2. So we can view this as in the form dy over dx plus p of x multiplied by y is equal to q of x. We can now see that p of x is a coefficient of y, which is -1, and then q of x is what is in the right hand side, which is 5.2. So we can now solve this by finding first the integrating factor, which is e raised to integral of p of x dx. So the integrating factor will be integral of p of x, which is -1 dx, and this gives us e raised to negative x. So after that we can write the general form, which is y multiplied by I of x integral of I of x multiplied by q of x multiplied by dx. So we have y e raised to negative x, which is going to be integral of e raised to negative x multiplied by 5.2 multiplied by dx. So we have y e raised to negative x, which is going to be equal to 5.2 integral of e raised to negative x will be e raised to negative x divided by -1, which will make this term to be negative, and then we say plus c. So that means finally we have y is equal to, when we divide by e raised to negative x both sides, you're gonna get e raised to positive x on the other side into c minus 5.2 e raised to negative x. So we're gonna get y is equal to we're gonna get y is equal to, when we remove the parentheses, c multiplied by e raised to x minus 5.2. So that's our answer. So now we can also view this as a separation of variables. Separation of variables. So to view it like that, so we're gonna say dy over dx is equal to minus y is equal to 5.2. So we can say dy over dx is equal to 5.2 plus a y. So I can now say now dy is equal to, when we multiply by dx both sides, 1 over, when we multiply by 1 over dx, in fact, on the left hand side dx will cancel the dx, and then on the right hand side we'll be left with what? We'll be left with y plus 5.2 multiplied by the dx, and then to separate the variable, this should be dy. Actually we're gonna get y dividing by y plus 5.2 both sides, y plus 5.2, and then dy, which is going to be dx. Integrating both sides, we get natural logarithm of y plus 5.2, which is equal to x plus c. So taking the second function of natural logarithm to the other side, we get y plus 5.2, which is equal to e raised to x plus c. So proceeding from there, we can say y, making y the subject of the formula, and separating e raised to x plus c becomes e raised to x multiplied by e raised to c, because e raised to x multiplied by e raised to c is the same as e raised to x plus c, and then minus 5.2, then we get y, which is equal to e raised to c is just a constant multiplied by e raised to x minus 5.2. So comparing the answers now, you can see that the answer we get here is exactly the same as the answer we got when we're using the linear, when we're viewing the equation as a linear differential equation. So now the second one, number B, we are having y prime, which is equal to 2y minus 4x, and then we can say dy over dx minus 2y is equal to negative 4x. Here we can view it in the form dy over dx plus p of x multiplied by y, which is equal to q of x. So you can see this is a linear differential equation, with p of x equal to -2 and q of x equal to -4x. So we can find the integrating factor I of x, which is e raised to integral of p of x multiplied by d of x. Now I of x will be e raised to the integral of -2 dx, and this just gives us e raised to -2x. So solving with the general equation y multiplied by I of x, which is equal to integral integrating factor multiplied by q of x multiplied by dx. So substituting into the equation now, we get y multiplied by I of x e raised to -2x, which is going to be the integral e raised to -2x multiplied by the q of x, which is -4x multiplied by dx. So we can say y e raised to -2x is equal to -4 integral e raised to -2x multiplied by x multiplied by dx. So we can use the integration by parts to say now y e raised to -2x is equal to -4 into uv minus integral of v du, and then we can now say now our u is equal to x, so that our du can be equal to a dx, and then we can say our v is equal to e raised to -2x, our dv is equal to e raised to -2x dx, so that our v now will be equal to e raised to -2x all over -2. So what we do there is that we integrate the dv so that we can get the v, and then we get e raised to -2x over -2. We put the function as it is, and then we divide by the derivative of the exponent. So now I'm gonna get y e raised to -2x, which is going to be -4 into u, and then our u is x multiplied by v, which is e raised to -2x all over -2, and then minus integral of v, and then our v is e raised to -2x all over -2, and then our du is the same as dx. So we're gonna get y e raised to -2x, which is equal to -4 into -1 over 2x e raised to -2x minus, when we take out the constant, they're gonna get plus 1 over 2 integral e raised to -2x dx, and then that's what we're gonna have. Y e raised to -2x is equal to -4 into -1 over 2x e raised to -2x, and then we can say now plus 1 over 2 times integral of e raised to -2x is going to be e raised to -2x divided by -2, and then we say plus a constant c. So what we have now, we have y e raised to -2x, which is going to be a -4 into -1 over 2x, -1 over 2x e raised to -2x, and then we have a -1 over 4 minus 1 over 4 multiplied by e raised to -2x, and then plus c. So after that we can say y e raised to -2x is equal to removing the parentheses by multiplying by -4. We're gonna get -4 times -1 over 2. We're gonna get 2x e raised to -2x, and then there we get -4 times -1 over 4 is plus e raised to -2x, and then plus c. So gonna get y is equal to, when we divide by e raised to -2, both sides is gonna be e raised to 2x into 2x e raised to -2x plus e raised to -2x plus c. So when we remove the parentheses, we're gonna get e raised to negative 2x times e raised to negative 2x is gonna be 1. That means we're gonna get 2x times 1. And then plus e raised to negative 2x times e raised to 2x, we get 1. And then e raised to 2x times c is gonna be c e raised to 2x. So that's what we have there. So that means now this is our solution. So let's go to the other one. So the other one we have problem number C, and then our problem number C we have y prime plus ky, which is e raised to negative kx. So you can say dy over dx plus ky is equal to e raised to negative kx. And then we're going to have this dy over dx is equal to dy over dx plus p of x multiplied by y is equal to q of x. So now we can see that now our p of x is equal to a k, and then our q of x is equal to e raised to negative k multiplied by x. So what we can do now is that we can actually treat this as a linear function. That means we can find a linear differential equation. That means we can find I of x, which is the integral of p of x multiplied by d of x. That's going to be e raised to integral of k dx, and then that should be e raised to k times x. So now general equation is I of x multiplied by y, which is the integral of I of x multiplied by q of x multiplied by d of x. So now we're going to have y multiplied by I of x, which is e raised to k times x, and then that's equal to the integral of e raised to k times x multiplied by the q of x, which is e raised to negative k times x, and then multiplied by dx. Y e raised to kx is equal to integral of dx, because e raised to kx times e raised to negative kx is 1. Integrating that, we get y e raised to kx, which is equal to x plus c. That means y is equal to x plus c multiplied by e raised to kx. So that is our solution. And then the next one now we have number D, and then our number D we have x multiplied by y prime, which is going to be 2y plus x raised to 3 multiplied by e raised to x. So now you can say now x multiplied by dy over dx is equal to 2y plus x raised to 3 e raised to x. Dividing by x, we get dy over dx is equal to 2 over xy, and then plus x squared e raised to x. So you can say now dy over dx minus 2 over x multiplied by y is equal to x squared e raised to x. You can see now the equations in the form dy over dx plus p of x multiplied by y, which is equal to q of x, with p of x being equal to negative 2 over x, and then our q of x being equal to x squared e raised to x. Then finding our integrating factor I of x will be e raised to integral of p of x multiplied by dx. So that means we have our I of x being equal to e raised to integral of p of x. Then we said our p of x is negative 2 multiplied by 1 over x, which is the same as negative 2 over x dx. So I get our y of x our I of x, which is going to be e raised to negative 2 integral 1 over x dx. So I of x, which is going to be e raised to negative 2 natural logarithm of what? Of x. So the integral of 1 over x. So we're going to have I of x, which is going to be e raised to a natural logarithm of x to the minus 2. And then this finally becomes 1 over x squared, or x raised to negative 1 over 2. So now y multiplied by the integrating factor is equal to integral of the integrating factor multiplied by q of x multiplied by d of x. Y multiplied by 1 over x squared is equal to integral 1 over x squared multiplied by q of x, which is x squared e raised to x multiplied by dx. So we have y over x squared, which is equal to x squared and x squared, they cancel on the right hand side. We're left with e raised to x multiplied by dx. So now we have y over x squared, which is going to be integral of e raised to x is the same as e raised to x plus c. So I get y is equal to x squared into e raised to x plus c. So that is our solution there. So now we have problem number E. Then our problem number E, we have y prime plus y sine of x, which is equal to e raised to cosine of x, where y of 0 is equal to negative 2.5. So now we can see that this can be written as dy over dx plus y sine of x, which is e raised to cosine of x. And then we can see that this is in the form dy over dx plus p of x multiplied by y, which is equal to q of x, with now p of x being equal to sine of x, and then with our q of x being e raised to cosine of x. So our integrating factor, we can see this is a linear function, linear differential equation, e raised to integral of p of x, which is sine of x dx. So we get I of x, which is e raised to integral of sine x is negative cosine of x, because the derivative of cosine x is negative sine of x times the negative sine, which will give us the positive sine of x. So after that, we can say now I of x multiplied by y is equal to integral of I of x multiplied by q of x multiplied by dx. So we have y multiplied by e raised to negative cosine of x, which is equal to the integral of e raised to negative cosine of x multiplied by the q of x, which is e raised to cosine of x multiplied by d of x. So now we can now proceed and say now y e raised to negative cosine of x is equal to integral of e raised to negative cosine x times e raised to positive cosine of x. That should be 1 times dx. So if y e raised to negative cosine of x, which will just be integral of 1, which will be x plus c. So y is equal to e raised to cosine of x into x plus c. That's our solution. So now is substituting the conditions. In place of y is negative 2.5, and then we get e raised to cosine of 0 in place of x into 0 plus c. So now if we find the cosine of 0, we find it to be 1. That means now we have negative 2.5 is equal to e raised to 1 multiplied by 0 plus c is c. Then that means now our c becomes negative 2.5 divided by e. That means our solution is y is equal to e raised to cosine of x into x minus 2.5 over e. So that's what we get. That's our solution there. So number F, what do we have? We have y prime is equal to into y minus 2 and then cotangent of x. So you can actually say dy over dx is equal to into y minus 2 cotangent of x, multiplying both sides by 1 over dx. We're gonna get dy, which is equal to into y minus 2 cotangent of x dx. Separating variables, we get 1 over y minus 2 multiplied by dy, which is equal to cotangent of x dx. Integrating both sides, we're gonna get natural logarithm of y minus 2 is equal to the integral of cotangent of x. Now what about the integral of cotangent of x? We don't know. I actually don't know what is the integral of cotangent of x, but I'm thinking it's natural logarithm of sine. But let's see. Now integrating a cotangent of x dx, we can say integral cotangent is the same as cosine of x divided by sine of x multiplied by dx. So what we're gonna get now, we can say u is equal to sine of x, so that du is equal to cosine of x dx. Integral of cosine of x all over u multiplied by, in place of when we're making now the dx the subject of the formula, will be du over a cosine of x. So we have here du over cosine of x. So now this cancel that, get integral of 1 over u multiplied by du. So now integral of 1 over u is the same as natural log of u, and then we say our u is sine of x, and then plus c. So that means here we have natural logarithm of sine of x and then plus c. So you can say now y minus 2 is equal to e raised to natural logarithm of sine of x and then plus c. So we have y, which is equal to e raised to natural logarithm of sine of x multiplied by e raised to c plus 2. So what we're gonna have now, we can say y is the same as e raised to natural logarithm of sine of x is the same as sine of x, and e raised to c is just a constant, c multiplied by sine of x and then plus 2. So we can also view that equation as a linear differential equation. So how do we view it as a linear differential equation? You can say dy over dx is equal to into y minus 2 cotangent of x, so that we have dy over dx is equal to, removing the parentheses, we get y multiplied by cotangent of x minus 2 multiplied by the cotangent of x. So you can say dy over dx minus y cotangent of x is equal to a negative 2 cotangent of x. So we can view it like that, so that we can say now dy over dx plus p of x multiplied by y, which is going to be q of x, where we can say our p of x is equal to negative cotangent of x, and then our q of x is equal to negative 2 cotangent of x. So you can say now at this stage our integrating factor I of x is equal to e raised to integral of p of x, and then our p of x is negative cotangent of x and then dx, and then I of x we have already said that is going to be e raised to negative. We said integral of cotangent of x is natural logarithm of sine of x, so that means this will end up being e raised to natural logarithm of sine of x raised to negative 1, which is just 1 over sine of x. And then now we can actually have y multiplied by I of x, which is going to be integral of I of x multiplied by q of x multiplied by dx. Then that's y multiplied by 1 over sine x, which is equal to integral of 1 over sine x times q of x. And then what was our q of x? It was negative 2 cotangent of x dx. So now we can say y over sine of x is equal to integral of 1 over sine x is cosecant of x times cotangent of x dx, and then we can put the negative 2 behind the integrating sign. So remember that now the derivative d over dx of cosecant of x is the same as negative cosecant x cotangent x. So that means the integral of negative cosecant x cotangent x will be a cosecant of x. So that means you can have y here all over sine of x, which is gonna be, if we take that negative inside, now we have 2 times the integral of negative cosecant of x cotangent of x is just cosecant of x, and then we say plus c, and then we can say y is equal to sine of x into 2 times cosecant of x is 1 over sine of x plus ac. That means if y is equal to 2 times sine of x is sine 2 sine of x. Okay, sine of x will cancel a sine of x, we get a 2, and then sine of x times c, we get a c times sine of x. So this is just equal to c sine of x plus 2, which is the same as what we got at first there, which is y is equal to c sine of x plus 2. So the next problem now, let's say number 1, because it's the problem based on Bernoli's equation, y prime plus y is equal to y squared, and we're given y of 0 is equal to negative 1 over 3. So you can say dy now over dx plus y is equal to y squared. So our equation now is in the form dy over dx plus p of x multiplied by y is equal to q of x y raised to n, where our p of x now will be equal to 1, and then our q of x is equal to 1. Can see now that the only difference is that in the y we have an exponent there, which makes it to be Bernoli differential equation. So now our integrating factor here will be slightly different. It will be e raised to integral of 1 minus n multiplied by p of x multiplied by dx. So that's going to be e raised to integral of 1 minus 2 multiplied by 1 multiplied by dx. So that giving us e raised to integral of negative 1 dx. That should be e raised to negative x. That's our integrating factor. And again, our solution now will be y multiplied by the integrating factor I of x, which will be equal to the integral of 1 minus n, and then obvious multiplied by I of x multiplied by q of x multiplied by dx plus c when we have integrated, which is, this should actually be y raised to 1 minus n. So when we make y raised to 1 minus n, the subject of the formula will get y raised to 1 minus n, which is 1 over I of x, and then that's into integral of 1 minus n I of x multiplied by q of x multiplied by dx plus c. So I can get y raised to 1 minus 2 is equal to 1 over e raised to negative x into integral of 1 minus 2 multiplied by e raised to negative x multiplied by q of x, which is 1, and then plus c. So you can say now y raised to negative 1 equal to 1 over e raised to negative x is e raised to x into negative integral e raised to negative x plus c. So you're gonna get now y raised to minus 1, which is equal to e raised to x now into integral of that, that's going to be positive e raised to negative x plus c. So we're gonna get now y to the minus 1, which is e raised to negative x times e raised to negative x, which is 1, and then plus c e raised to x. So that means if you wanna make y the subject of the formula, y should be 1 over 1 plus c e raised to x. So that's how we can solve the problem. So the second one, based on Bernoli's equation of y prime plus xy, which is equal to xy to the minus 1, and we are told that y of 0 is equal to 3. Also here we can find because when given the conditions, that means we can actually find the solution using the initial values. So we have y of 0, which is equal to negative 1 over 3, meaning that y is equal to minus 1 over 3, and then x being equal to 0. And then we have found that y is equal to 1 over 1 plus c e raised to x. That means in place of y put negative 1 over 3, which is equal to 1 over 1 plus c e raised to 0, which is going to be 1. We get negative 1 over 3, which is 1 over 1 plus c, and then negative 1 over 3 into 1 plus c is equal to 1. So we can multiply by negative 1 over 3 both sides, multiply by negative 3 both sides. We will get 1 plus c, which is equal to negative 3, and then c should be negative 4. So from there we can say now y should be 1 over 1 minus 4 e raised to x. So that's our final solution there. So coming here, we're gonna get dy over dx plus xy is equal to x y to the minus 1. So you can see now is in the form dy over dx plus p of x multiplied by y, which is equal to q of x y to the n, where our p of x is equal to x, and then our q of x is equal to x, and then our n is equal to negative 1. That means our integrating factor, this is Bernoli's equation, is e raised to integral of 1 minus n multiplied by p of x multiplied by d of x. This becomes e raised to integral of 1 minus 1, which is become positive, and then times p of x, which is x dx. So that's gonna be e raised to 1 plus 1 is 2, and then integral of 2x is x squared, because the derivative of x squared is 2x. That means our solution now we're going to get now our y raised to 1 minus n, which is 1 over I of x into integral of into 1 minus n I of x, and then q of x dx plus c. So we're gonna get y raised to 1 minus 1, 1 minus negative 1 is 2, which is equal to 1 over e raised to x squared, which is e raised to negative x squared, and then into integral of 1 minus negative 1, which becomes 2 times I of x, and then we find our I of x to be e raised to x squared times q of x, and then our q of x we said is x, and then dx plus c. So you can see that integrating that will use u substitution. We can let our u to be equal to x squared, and then our du should be 2x dx, such that now our dx will be du over 2x. That means of y squared, which is going to be e raised to negative x squared into 2 integral of e raised to u multiplied by x, multiply in place of dx we put du over 2x, and then plus c. So y squared should be e raised to negative x squared into 2, x cancels x there, and then this 2 cancels that 2. That means now we are left with integral of e raised to u, which will just be e raised to u, and then in place of u we set our u becomes x squared, and then plus c. So I think we have integrated our equation correctly. So you can say now you can say y squared is equal to e raised to negative x squared times e raised to x squared. That's gonna be 1 plus c e raised to negative x squared. So substituting the values that were given, y of 0 is equal to 3, we have y squared which is equal to 1 plus c e raised to negative x squared, and then we're given y of 0 is equal to 3. Then that means we have 3 squared which is equal to 1 plus c e raised to 0. So that means we have 9 is equal to 1 plus c, and then our c should be 8. That means we have y squared which is 1 plus 8 e raised to negative x squared. So that's our solution. Obviously, maybe if you are to make the y of the subject of the formula, you can simply say y is equal to the square root of 1 plus 8 e raised to negative x squared. So next problem. Problem number 3. We're having y prime minus y, which is equal to xy squared. That means if dy over dx minus y should be xy squared. That means our I of x should be equal to e raised to integral of 1 minus 2 times p of x, which is negative 1 multiplied by dx. That means our I of x should be equal to 1 minus negative minus 2 is negative 1. Negative 1 times negative 1 is positive 1. We're left with e raised to the integral of dx, which is going to be x. That's our integrating factor. So after that, we can say now y raised to 1 minus n is equal to 1 over I of x into integral of 1 minus n multiplied by I of x multiplied by q of x dx plus ac. So you can say y raised to 1 minus 2, which is going to be 1 over x e raised to x, which is e raised to negative x, into integral of 1 minus 2, which becomes negative 1 times I of x, which is e raised to x times q of x. And then what does our q of x is equal to x is actually what we get there. That's our q of x. So multiply by dx plus c. Seems like this is going to need integration by parts. Y to the negative 1 is equal to e raised to negative x into negative, and to integral of e raised to x times x is uv minus integral of v du, and then plus c. So we can actually make our u to be equal to x, so that our du becomes dx, and then our dv to be e raised to x dx, so that our v be equal to e raised to x. So you can have 1 negative 1 is equal to e raised to negative x into negative into x u times v e raised to x minus integral of v e raised to x, and then dx, of course, plus c. So that is what we have there. That is what we have there. So that means we have 1 over y, which is equal to e raised to negative x into negative multiplied by x e raised to negative x minus integral of e raised to x is just e raised to x, and then plus c, and then get y over y, which is equal to e raised to negative x into negative x e raised to negative x plus e raised to x. And I believe that should have been a positive x, not a negative x. This should have been a positive x plus c. So that means 1 over y should be negative x, and then plus 1 plus c e raised to negative x. That's what we should have there. So that's our solution to the equation. So this is our solution to the equation. We can make y the subject of the formula if we are asked to do so. So now let's go to the next problem. So problem number 4, we are having x dy over dx plus y is equal to x squared y squared. So we can divide by x first and we get dy over dx, and then we get plus 1 over x times y, which is equal to xy squared. You can see this is Bernoli's equation by the exponent 2 there and by the y there. So what we can say now is that I of x should be equal to e raised to the integral of 1 minus 2 multiplied by 1 over x dx. That means now we have e raised to negative 1, 1 minus 2 is negative 1, and then integral of 1 over x is natural logarithm of x. That means we get 1 over x there as our integrating factor. That means now y raised to 1 minus n is equal to 1 over I of x now into integral of 1 minus n multiplied by I of x multiplied by q of x multiplied by dx plus c. So that means if y raised to 1 minus 2, which is equal to 1 over x, which is x, into integral of into 1 minus 2 multiplied by 1 over x multiplied by q of x, which is x. Yes, our q of x is x multiplied by dx plus c. Because remember now our q of x will be this portion of the equation. So after that we can get y to the minus 1, which is equal to just x into negative integral of this x cancels x, integral of dx plus c. That means 1 over y should be equal to x into negative x plus c. So this is actually our solution to the problem. So we are not having any initial conditions. So now what we can do again, we have x squared y, which is problem number 5. We have x squared y minus y raised to 4 cosine of x is equal to x raised to 3 dy over dx, of which I also believe that this is our last problem. So now we can actually, first things first, we can put this and rearrange this as x raised to 3 dy over dx, which is equal to x squared y minus y raised to 4 cosine of x. So you can say now dy over dx is equal to, when we divide both sides by x raised to 3, you're gonna get here 1 over x multiplied by y minus y raised to 4 multiplied by cosine of x over x raised to 3, and then you can say dy over dx is equal to, okay, we can take 1 over minus 1 over x times y to the other side, and we get y raised to 4 multiplied by negative cosine of x all over x raised to 3. So you can see now this is in the form dy over dx plus p of x multiplied by y, which is equal to q of x y raised to n, with our p of x being equal to negative 1 over x, with our q of x being equal to negative cosine of x all over x raised to 3, and then our n is equal to 4. So that means now our integrating factor I of x is equal to the integral of e raised to into 1 minus 4 multiplied by p of x, which is negative 1 over x multiplied by dx. So that's going to be in e raised to negative 3 integral, of which negative and negative they become positive actually, 1 over x dx, and then this becomes e raised to 3 natural logarithm of x, and this becomes x raised to 3. So you can say now y raised to 1 minus n is equal to 1 over integrating factor into integral of 1 minus n multiplied by q of x multiplied by I of x multiplied by dx plus c. So you can say y raised to 1 minus n, and then what is our n? We said is 4, which is 1 over x, which is the same as x to the negative 3, into integral of into 1 minus 4 multiplied by the q of x, which is cosine of x, over x raised to 3 multiplied by the integrating factor, which is x raised to 3 dx plus c. So you can say y to the minus 3 is equal to x raised to negative 3 into negative 3 integral that, cancel that, we're left with cosine of x dx plus c. So that is what we have. So you can say now y to the minus 3 is equal to x to the minus 3 into negative 3 integral of cosine is sine of x and then plus c. Or we can put this as x raised to 3 is equal to y raised to 3 into c minus 3 sine of x, and then that's our that's our that's our solution there. So this is how we can solve problems that have to do with Bernoli's equation and the and the and the separation of variables.